Hey guys, welcome back. So today we're going to talk about current in this lesson. What's current? What are the variables and the formula for current? And what are the conditions that we need to have for current to flow? All right, let's jump right into it. So what is current? Well, first off, current is a flow of electrons through a conductor. So if we remember back in early science, we have these two things. We have either a conductor or an insulator. This allows electrons to flow, where insulators like rubber do not. So if I want electrons to flow, I'm going to need a conductor. The symbol that we're going to use to represent current is going to be capital I. Current has a symbol of capital I. And a unit of ampere, or as we just say for short, amp, or capital A. All right, and the way it's shown as there is going to be some sort of circuit where we are going to have electrons flow through that circuit and create a current. Now, to solve for current, we're going to say current is equal to the amount of charge, a change in charge, divided by how fast that charge is moving. Now, there's a couple of things that we're going to need to look at here, and more specifically when it comes to this Q. This is a charge. This is a change or amount of charge, not electrons. So although electrons are commonly the thing that's going to be moving here, this delta Q is how much charge is moving, not how many electrons. So we'll remember that sometimes we're going to need to be able to convert charge to electrons and electrons back to charge. So that's from our earlier lesson. And this is just time in seconds. Now we see this, it says, what conditions must there be for current to flow? All right, so if I look at I equals delta Q over T. This is the charge through a wire, so this is an amount of charge. But this is a charge that goes by a given point, passes a point. So essentially, when we're if this was the wire, what we're doing is we're going to look at one specific spot right here, because inside this wire, there are going to be a bunch of electrons. And they're all just back to back, packed in here very tightly in this conductive wire. So when we're measuring current, what we're doing is we're looking inside this box and we're saying how many electrons pass per time. And that's where the delta Q over T comes in. Okay? Now there's going to be some other conditions that are going to have to happen. So number one, for electrons to flow / current to flow. Number one, I need a closed loop. Meaning electrons need somewhere to go. And we'll explain more of that when we get to circuitry. So this is what I mean is a closed loop. So for example, a switch, what we'll see in a circuit, a switch breaks the loop. That's why the lights go off. The next thing is you need that loop to be made of a conductor. All right, so generally we use copper, all right, but you can't make a circuit out of rubber, right? The loop needs to be made of conductor so electrons can flow. And last, there must be a potential difference, which we learned about in the last unit. And remember that potential difference is given by a capital V with a unit of volts. All right, now this whole picture, okay, it'll become more clear as we go on, and we'll talk about these certain things that are going to need to happen. But for right now in this lesson, you need to know what the difference between the current is and this potential difference. This part right here with switches and things, that's where we're going to build up to when we start to get to circuits. So let's take a look at an example. A total of 20 coulombs of charge passes a point in a conductor in 4 seconds. Calculate the current inside. So like I just drew, if I have a wire that has a bunch of electrons in it, and these electrons are flowing this way, now electrons carry charge. So I could see, if I look at one given point, they're saying a given point. So if I were to look right here, how many charges go by in 4 seconds? So this is where I equals how much charge is going to go by in a given time of 4 seconds. Okay? And this is going to tell us our current. So we were given Q. Coulombs is a charge for Q. So 20 coulombs goes by in 4 seconds. If I divide this, I will get an answer of I equals a certain amount of coulombs per second, which is ampere. Looking at another example, a wire carries a current given of I equals 2 amps. How many electrons go by this point in 1 second? Now guys, remember, this is from an old topic. When we had to go from a charge to an amount of E, and we had to also be able to go from E to an amount of charge. Remember where E was an elementary charge. All right? So when I use this formula and I say that I equals delta Q over T, I am given 2 amps. And am I given this? Guys, remember, please, and this is so, so important, this is not how many electrons. Delta Q is equal to how much charge, which then, after you know how much charge, that must be converted to an amount of E's. And you could do that right now. All right, guys, so that's pretty much your intro to current. Next will be resistivity. If you need to go back and watch videos on this, I would do that, but I think you should be able to remember. But watch out for questions like this, guys. They pop up very, very often.